Hi guys, today I'm going to explain you about how blockchain works in a simple way. More specifically, what is blockchain, how it works, why is it so secured, and why is it so popular. Blockchain technology concept was originally described in 1991 by a group of scientists to timestamp digital documents. However, it was first implemented by Satoshi Nakamoto for Bitcoin in 2009 to create a digital cryptocurrency called Bitcoin. Bitcoin is a cryptocurrency and blockchain is the technology that supports it, and they are connected theories. Throughout my lecture, essentially, I will explain blockchain technology using a public blockchain like Bitcoin blockchain. Blockchain is a distributed, decentralized database that is shared across a network. If you can understand how Google Docs or Google Sheets works, then it's a bit easy to understand how blockchain works, although Google Docs is not technically a blockchain. With Google Docs, multiple people have access to the same document and can edit and see the updates at the same time from different locations. On the other hand, in a blockchain, everyone can see the transaction. However, nobody can alter once it is established. The Bitcoin blockchain is the oldest blockchain in existence, and it is revolutionary because it enables the world to conduct any transaction without the need for a middleman. The heart of the blockchain is moving from the centralized trust to distributed trust or to universal trust. This is the beauty of the blockchain. Let's talk about how blockchain works. Essentially, blockchain is the electronic version of the paper ledger or collection of transactions or a distributed ledger technology that permits data or transaction to be stored globally and securely in a massive number of computers or servers, and we call them nodes. So theoretically, blocks of data or a blockchain exist on these nodes. All these nodes in the blockchain are contributing to verify and validate transactions. Blockchain is a chain of blocks that contains information. Let's assume blocks of digital data. The first block we call Genesis block. Blockchain allows anybody in the network to see every other person's records in real time, so it provides the transparency. These blocks are chained together, and this makes the data immutable or immutably linked together, as you can see. Once data or a block has been added to a blockchain, it can never be changed again. So it's a secure, tamper-proof database or tamper-proof ledger. If malicious user wants to hack one block, he has to chain the entire chain. Once the data is entered to a blockchain as a block, it is timestamped and digitally signed as the proof of integrity. A timestamp is a proof that the contents of the block existed before a specific point in time. Therefore, the information in blocks cannot be backdated. Literally, it would be extremely difficult to change it. However, there is an exception, though I will explain it within the next few minutes. Blockchain provides an immutable transaction tracking history, so it provides the traceability. However, still it is anonymous. Blockchain stores data or transactions in a distributed ledger that potentially many can access and update securely. So now the obvious question is, who has access to this information? Depending on the blockchain type, whether it's a public, private, or consortium, you will get the access. Let's talk about how this happens. Public blockchain or permissionless blockchain enables anyone within an internet connection to participate in the verification of transactions and to establish as a node. A fully transparent ledger, every single transaction is public. However, users can control individual anonymity. Private blockchain or permission blockchain provides one party to have full control, and they will choose a few nodes that are predetermined. So, on the other hand, private blockchain allows the middleman back in to a certain extent. Organization can also determine who has read access to their blockchain's transaction, providing better privacy than a public blockchain. Consortium blockchain accommodates many of the equal benefits as the private blockchain, such as transaction privacy, efficiency, etc., without connecting power with only one party. So it operates under the leadership of a group rather than one party or pre-selected nodes in the consortium. In public blockchain, for example, Bitcoin blockchain, the information will be publicly available to anyone who wants to see it at any time. This is groundbreaking because it allows us to keep track records of pretty much anything: property rights, identities, tax payments, money balances, medical records, etc., without being at the risk of someone tampering with those records. For example, Bitcoin and Ethereum are public blockchains. However, if we need, we can control who can get the access to information by using private or consortium blockchains. For example, Hyperledger Fabric and the recently launched Libra blockchain by Facebook. Blockchain is a way to save data and make it immutable. So the key features of blockchain are the decentralization. It is very transparent, so we can trace who did what and when. It is anonymous. It is immutable, blocks immutably linked together. Consensus. It maintains a distributed setting or making rules. More specifically, it maintains a global trust. Let's talk about what's a peer-to-peer network in blockchain. Peer-to-peer networks are essentially solid and secure, and more importantly, they have no central authority. Peers are computer systems connected to each other via internet. Each peer keeps the same copy of the entire blockchain ledger to limit a single point of failure. So transaction updates and validations are reflected in all copies simultaneously. The beauty of blockchain is that peers can make transactions to each other directly without intermediary trusted third parties. This is really a cool idea. For example, transferring money from country one to country two, that sounds great. But the big question is, how does that work? Let's try to understand that. Now I will explain a little bit more details on blocks in a blockchain. Each block has the block body, data or transactions, block header, which contains the hash of the block, the hash of the previous block, nonce, difficulty value, timestamp, and Merkle root. A nonce is an arbitrary number which can be used just once in a cryptographic communication. I will explain more on nonce, difficulty value, and Merkle root in another time. Each block has the data. For example, in Bitcoin blockchain, data could be sender, receiver, and dollar amount information. In healthcare, it could be patient healthcare records. The data is saved as on-chain data or off-chain data, depending on the type of blockchain. However, in general, blockchains are not good for storing a large amount of data as it creates network limitations and other costs. So it may not work efficiently. So we store the hash of the data and links to any off-chain data on the blockchain. The hash function is a piece of complex cryptographic math or cryptographic hash function. This is what makes the blockchain secure. It's a unique signature like a fingerprint. In fact, the hash output we call digital signature. Bitcoin blockchain uses SHA-256 hashing algorithm. A hash function converts any length, any type of data, for example, text, numeric, image, voice data, into a short alphanumeric code with fixed size length or hexadecimal string, or let's say into a 256 bits binary string. I will explain you this with an example. Let's say we use 256 hash function. I'm trying to hash my name, Malka. So let's say this is the hash output, binary hash. Now I change one character of the data. For example, instead of capital M, I use simple m. Then almost the entire hash function of the altered data is changed. This is a 256 length binary string with ones and zeros. So to crack this, a malicious user should try 2 to the power 256 different possibilities. It is practically impossible. The hash value changes when a single bit of data within a file is changed, and it remains the same for the same data. It is easy to turn regular data into a hash, but nearly impossible to reconstruct the original data from the hash, so it is irreversible. The hash is useful when we want to detect any change made to a block by a malicious user, so we save hash of the data in the blockchain. Computers these days are very powerful, and they can calculate trillions of hashes per second. Next important part of the blockchain is the hash of the previous block. As you can see, it always connects to the next block. This effectively creates the chain of blocks immutable. Each block is time-stamped, and those timestamps are used to order blocks as they are added to a blockchain. When a transaction is added in a blockchain, let's say price, property details, or patient healthcare records, the blockchain will be updated across all nodes within seconds. Change in one block could change all the connected blocks to become invalid. So we have to calculate hashes again to validate all blocks. Then the blockchain is valid again. Let's talk about another security feature of the blockchain, consensus algorithm for block validation. All nodes in the blockchain network create consensus or general agreement or some rules. They agree on which blocks are valid and which are not, and which order new blocks should be added to the chain. This is the mechanism that users or nodes in blockchain use to maintain a distributed setting or makes rules. For example, approving transaction on a chain, Bitcoin blockchain needs approval from 51% of existing nodes to accept a new transaction. Proof of work is the original consensus algorithm or consensus protocol in a Bitcoin blockchain network. Literally, the consensus algorithm is the mechanism that controls the creation of new blocks in a given time. For example, Bitcoin blockchain usually takes 10 minutes to calculate proof of work and to add a new block to the chain, while in Ethereum it is between 10 to 20 seconds. Depends on the blockchain type, they use different consensus algorithm. Bitcoin blockchain is a public blockchain and it uses proof of work algorithm. Ethereum is a public blockchain and it uses proof of work and proof of stake algorithms. Hyperledger Fabric is a consortium blockchain and it uses Byzantine fault tolerance algorithm. And the recently launched Libra blockchain by Facebook is a private blockchain and it uses Libra Byzantine fault tolerance algorithm. With proof of work, miners are solving complex mathematical problems to compute the hash function. A person or a node who does this work first gets the opportunity to add the new transaction or block into a blockchain and gets the block reward. This process is known as mining, and the nodes which are involved in mining process are called miners. The complexity of this mathematical puzzle depends on the network load, blockchain size, and how many active users are there, etc. So we need computational power to solve this puzzle. To maintain a blockchain, we need computation power, we need necessary hardware, we need electricity, we need time. So obviously we need money. From where we get that? Incentive mechanism plays a role here. For example, it takes 10 minutes to mine a new block to the Bitcoin blockchain, and the block reward is 12.5 Bitcoins. On top of this, a small transaction fee is charged on every new transaction. This is again depends on the blockchain type. Blockchain is in principle secure due to its creative use of hashing and consensus mechanism. I will explain the blockchain transaction process using the Bitcoin blockchain. Transaction: two parties in a network is engaged in a digital transaction. Verification: the requested transaction, considered as a new block, is broadcasted to the other blocks in the chain. Validation: others use agreed consensus algorithm to validate a new block. Miners verify the transaction. Structure: new block. Once the verification is confirmed, the transaction is combined with the other transaction to the chain as a new block. Now the block is locked with the cryptographic hash. This cannot be changed and it is permanent. Last step is the completion. Once a new block is added to the chain, then it is considered as complete. So every node in the blockchain network automatically gets this update in their ledger. What if a malicious user tries to tamper with a block in a blockchain? To successfully tamper a blockchain, essentially, he would need to tamper all consequent blocks on the chain. Redo the proof of work for these consequent blocks, as blocks are mutually linked together. Take a control of more than 51% nodes of the peer-to-peer network. Let's say a malicious user has changed a block of transaction and is immediately trying to calculate new signatures for the consequent blocks to have the rest of the network trust his change. The issue for him is that the rest of the network is continuously calculating new signatures for new blocks. The malicious user will have to calculate new signatures for these blocks too, as they are being attached to the end of the blockchain continuously. Moreover, he needs to retain all the blocks linked, including the latest ones regularly being added. Except if the malicious user has more computational power than the rest of the network combined, he will never find the remainder of the network discovering signatures. As you can understand, this is literally impossible to do. Let's talk about why is blockchain secure. It is secure due to the strong immutability feature, peer-to-peer networking, digital signature using the complex cryptographic hash function, and the strong consensus algorithm. Why is blockchain very popular? It is trendy due to few reasons. A, it maintains a distributed trust. B, it is immutably linked together. C, it provides the traceability and transparency. Due to these high security features, many organizations, including government, gradually integrate blockchain into their business models. Blockchain has the potential to change the way we buy and sell, secure data, interact with government, including the authenticity of property titles, and the way we organize supply chain, healthcare, and even how to get secure internet infrastructure, leading to cybersecurity. As said before, blockchain maintains a global trust. That's all, guys. Let's catch up soon with other short lectures with more details on how consensus mechanism in blockchain works on a deeper level and also how a smart contract works. If you think this video is useful, please share with others. See you guys soon.